Okay, so in the next question here, it will just be simply classifying each molecule as an aldehyde, ketone, or neither. So with that, let's just get a head start here and just make our tables. So we have aldehyde and ketones and a neither group. Okay, so 3 groups here, and now let's actually write down what we know about these 3 groups. Well, the neither, we won't have to really write anything, but for aldehydes, actually, one of the ways they give away is the name. The name usually for aldehydes ends in AL if it's a primary group. That's how you classify an aldehyde. For ketones, the way they usually end is an ONE, okay? And neither, they don't end with either or. And the other thing about aldehydes is that the way they work is there's a functional group, okay? All right. And then it's attached to the carbon, but the carbon is attached to an oxygen and a hydrogen at the end. This right here is an aldehyde. So just move that a little bit lower for you to see. So this is an aldehyde group. It has that functional group, carbon, and the hydrogen. Now ketone looks very similar to that, but instead of it being a hydrogen, you'll see that it's just another functional group. So ketones is when the double bonded oxygen is just in the middle of the functional group, quote unquote, while the aldehyde is actually in the end because you see the hydrogen there. Okay, so now knowing that, let's go forward and answer these questions. So let's start with the first one, hexanol. Right away, you see the name ends with AL, so hexanol is an aldehyde. Okay. Ethanol, same thing, AL, aldehyde. So very handy to just write down what you know about it. That way you get familiar with it. 2-methyl-1-butanol, also an aldehyde, if you guessed it, because same thing. Okay, so right now we have 3 aldehydes. Let's just go through the names first, because I do feel like that one's a little bit easier to grasp, because it kind of just tells you the answer right in its name. Propanone, another example of, well, not actually, not another, but another example of using its name, ends with ONE, so that would be a ketone, right there. And heptanone, well, 3-heptanone, same thing, ends with a ONE. Alright, so we have that. And methyl hexanoate, that one doesn't end with an AL or ONE, so we can put that safely in neither. Fun fact, actually, when it ends with an OATE, that's actually an ester, so definitely doesn't fit with an aldehyde or a ketone. And methyl propanoate, same thing. Okay, and pentanoic acid, that one, it says it right there in its name, it's actually a carboxylic acid, so it's neither as well. Okay, and now let's go over to the formulas. So we see F bonded CHO, so let's just draw it out and then move it to the right place. Okay, so really it's a fluorine, a benzene ring, better benzene ring. Okay, and right here CHO. The only way for this to be bonded to CHO would be CHO, yes, but C still needs that 4 bonds, and oxygen does have 6, so it needs 2 more, just like 2 bonds for to fill this space. So that's why we have a double bond here. So with that being known, if this is what we're given, okay, this right here tells us this is an aldehyde, functional group with the fluorine and the benzene ring, then it ends with double bond to C and an H at the end. So this right here is an aldehyde. Okay, and now we have CH3, CH2, 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 CHO. You see right away there is a double bond, and it's on the last C carbon, so you can kind of tell that it's going to be an aldehyde. But this formula will kind of look something like this. So there's 1, 2, 3, 4, 5. So kind of like this. 2, 3, 4. Okay. And on the last one, it would be 1, 2, 3 carbon. Yep. And then it'll be like an H here. And then this will be done by to oxygen. So this is what that formula would look like. So that right there is the same thing over there, and that one is also an aldehyde. Let me just draw a nice line through it. Okay. If we go over to the next one, that one, if we draw it, we get something like this. 1, 2, 3, and the oxygen is down here. But you see that there's the carbon right after it. This right here, this will count as a ketone because not followed by hydrogen, it's followed by oxygen. Okay, so just like our picture shows, 2 functional groups on each side, that's a ketone. All right, and then if we did the same thing, so that one looks like 1, 2, 3, 4, 5 carbons. So what I usually do is draw quote unquote 4 lines out of it because this is 1, 2, 3, 4, 5. This is just how I'm drawing my carbons. Okay, and we see that the oxygen is on the 4th carbon, so something like here, and that one is also going to be a ketone. Okay, and then we have the last 3 here. We have something that looks like this. Okay, that one's just an alcohol. In fact, this is going to be ethanol because 2 carbons and an OH. So that one goes over in the neither group. And this one, whoops, better lines. Because CH3, CH2, CH2OH, this one's just propanol. Also an alcohol. And now for the last one, we have CH3, CH2, then there's a, there's an O, and then it keeps going on like that. And this one right here, because the O is right there, as you'll learn, this is actually what you call an ether. So a strange one, but no dice. It's neither an aldehyde or a ketone. So we've gone ahead and broken down all the 15 of them and where they belong. And that would be how you classify each of these molecules. So let's see how it was done. So with that, they seem to have tackled, interesting, only the ones that, well, they didn't put all of them, that's for sure. But it looks like they're on the right track. They did show that the aldehydes are those that have the functional group on one side and hydrogen on the other. So that's good. Ketone, they did show that there's 2 functional groups on either side, and neither, they just put everything else there. So that is correct. And so with that, let me just put correct but incomplete. They did have the right basis for this question, so I'll mark that as correct. So let's go on to the next one here.